So it's a great pleasure for me personally to welcome this afternoon Professor Nidhal Guessoum, who's Professor of Physics from the American University of Sharjah in the United Arab Emirates. And I've known Nidhal now for a number of years, and we seem to overlap at a lot of different conferences and even Al Jazeera television once, wasn't it, as well? So we've both been on Al Jazeera and done various things together, and I've always very much appreciated Professor Guessoum's approach to the whole area of science and religion, and we have a huge amount there, I think, in common. I won't tell you all of his various scientific accomplishments. They're in your bio materials, which I think are in the handouts. Just to point out that he spent 2 years with NASA, the Goddard Space Flight Center, and therefore has an overlap with Jennifer Wiseman, another speaker from later on this week. We seem to have done well with NASA somehow this week. I think, anyone else have NASA? I think we've only got 2, but anyway. But we're delighted that Nidhal has agreed to give us a couple of talks this summer, and the first talk is going to be more historical, Islam and science yesterday. Thank you, Nidhal.
Thank you very much, Dennis, and thanks to Rodney and Zoe and the whole Faraday Institute for this kind invitation. I am absolutely delighted to be here in this first visit to Cambridge, actually, and first participation in your course series. I hope everybody has had some coffee, because I cannot guarantee that I will not bore you to death. I don't have the eloquence of John Hadley Brooke or Roger Trigg this morning, and that is why I need the PowerPoint slides. They're mostly for me, although I have found from my teaching experience that they tend to be useful to the audience as well, since people have different learning styles. You know, people like to read, people like to listen, people like to visualize, and so forth. So there will be 2 talks by me today and tomorrow. The first one will focus on the past, and tomorrow's talk will focus on the present. I'm not so much interested in the history, and that is why I changed the title a little bit from what is in the program. In the program it says Islam and Science, the History, although this will cover a lot of history. But it's not the history that interests me. It is the interaction between Islam and science, or science and religion in general, the ideas, the process, the institutions, the methodologies, the positions of the religious people and the scholars, the philosophers, etc. So what I want to do, even though I will need, since the audience is not familiar with this material, I will have to go back from sort of beginnings and go with you step by step to the development of the Islamic civilization in general, the science, what kind of science was developed, what were the strong points, etc. But toward the end, as you will see, I will try to get to the ideas. What were the sticking points? What were the main features? Was science during that time envisioned and practiced in a different way? What made it harmonious or in conflict with religion, theology, philosophy, and so forth? Here's the outline for you. I will mention very briefly the fact that there is currently a renewed interest in the history of the Arabic Islamic science, and I will get a little bit later as to the name. How do we refer to it? Is it Arabic? Is it Islamic? Arab science? What is it? The fast development of the Islamic civilization, this will still be the introductory part of the talk. How did science emerge and develop, evolve in the Islamic civilization? And I will point out in particular that there were some special needs, some special Islamic needs for science, particularly for astronomy, but for other fields, and that's what helped it develop that kind of science. What were the institutions of science then? How was science practiced? Was it universities? Was it research centers? What was it? So this, briefly, I will try to give you an idea. Were Muslim scientists, quote, as one historian of science put it early in the 20th century, curators of the Museum of Greek Science, or were there really some truly Islamic scientific accomplishments? I will try to shed some light on that. What are the concepts? Then this is sort of the latter part of the talk. What are the concepts of science and knowledge in the Islamic culture? Are they different from modern science, or similar? Did that help in the fusion or bridging between the two, science and philosophy / theology, etc.? The decline of Islamic science, a big question as to, we know for certain that it declined drastically. I could give a whole talk as to what kind of dramatic state it got to later. But that's not what concerns me. What concerns me is try to look at the factors, the reasons that made Islamic science, Islamic culture, civilization decline. And you will see that we do not have definite answers for that, but I will throw up a few factors for thought, and then in the end, the summary in terms of conclusion. There has been, as I mentioned briefly, renewed interest in the history of Arabic Islamic science. Just over the past 6 months, there were 2 series on BBC, one on BBC TV and one on BBC Radio. I just want to mention a few quotes from the 3-part BBC TV series, Science and Islam, which ran in January 2009. Jim Al-Khalili, who is a physicist, I think he's at Exeter or someplace, but is of Iraqi origins, did the series in sort of Cosmos style. He went around from place to place and measured things and carried the astrolabe and made the measurements and so on. Here's what he said about a person that I will identify in a minute. He said, Isaac Newton is the undisputed father of modern optics, or so we are told at school. Yet, in the field of optics, Newton himself stood on the shoulders of a giant who lived 700 years earlier. Ibn al-Haytham is the giant that he is referring to. He goes on to say, these are all words from Jim al-Khalili, without doubt, another great physicist who is worthy of ranking up alongside Newton is Al-Hasan ibn al-Haytham, who lived between Iraq and Egypt in the 10th century, 10th, 11th century. Ibn al-Haytham is regarded as the father of the modern scientific method. I think this is quite a bit exaggerated. I don't agree with Jim on this. Most people in the West will never have even heard of him. I certainly agree with that. But Ibn al-Haytham is certainly a giant. Maybe not at the level of Newton, but a giant. I want to give you just a quick idea as to why Ibn al-Haytham is considered a giant, why he was so revolutionary, why he produced, in optics at least, some monumental, and whatever I put between quotes, it means I am taking this from citations, from people who refer to this. These are not my words. So when I say monumental quote optics, it means somebody referred to the book of optics by Ibn al-Haytham, De Aspectibus, as a monumental work, a mathematical theory of vision. These are diagrams, which I will just skip, just showing you for illustration purposes, taken from an article that was written by Sabra, Abdul Hamid Sabra, from Harvard, now emeritus professor, is the prominent professor of Islamic history of Islamic science, the main expert on Ibn al-Haytham. He wrote an article from which I took these images and these words, and I have the reference down here. Ibn al-Haytham combined experimental investigations of the behavior of light with inventive geometrical proofs and constant forays into the psychology of visual perception, all systematically tied together to form a coherent alternative to the Euclidean and Ptolemaic theories of visual rays issuing from the eye, because Ibn al-Haytham was the first to show experimentally that clearly vision proceeds from the object to the eye and not the other way around. So this is just one thing. This is another diagram, not from Ibn al-Haytham, but just to illustrate the camera obscura, which was something that he developed, even though he failed to develop or to invent a film which would have really produced a camera, real camera, with photographs 1,000 years ago. So he produced something that could sort of make an image somewhere, but not to record it. So that tells you this is 1,000 years ago. Other great scientists, very quickly, Al-Kindi, who is the first big philosopher of the Arab Islamic tradition, said the following. He said, "Our goal must be to garner the truth from wherever it may come, for nothing is of higher priority to the seeker of truth than truth." So they tells you what kind of methodology, what kind of principles they put there. This is Al-Kindi on a stamp commemorating him recently. 2 others I want to mention for several reasons, even though I don't have time. One is Avicenna, who is very famous as a physician, although he should be even more famous as a philosopher, Aristotelian philosopher, and all-around polymath. He said on the importance of requiring proof, he who gets used to believing without proof has slipped out of his natural humanness. So that tells you what kind of standards he put and what kind of principles he believed in. Still, a person that I believe is of even higher caliber as a scientist and as somebody who upheld methodology to the highest degrees is Al-Biruni. Al-Biruni lived in what is today Afghanistan, so it tells you how far back we have gone. Al-Biruni, again, huge astronomer, physicist, traveled in India for 20 years, wrote books on India, spoke 4 or 5 languages, was actually a Persian but wrote in Arabic, etc., etc. Adopted induction as the valid approach for research and debated it with Ibn Sina. He had, Ibn Sina being Avicenna, he had a long correspondence with him, exchanging long letters, asking tens of questions, getting responses, rebutting, and so forth. And at some point he says to Avicenna, Ibn Sina, he says, the difference between me and you is you're a philosopher and I'm a scientist. This is the first time in the history of the Islamic civilization that we see this clear-cut distinction. He says, you proceed by deduction, I proceed by induction. And we heard this morning the discussion about induction induction and deduction. Flurry of recent books on the topic. Still, this is sort of today's renewed interest in the Islamic science. There's the House of Wisdom, which actually I carried with me. I'm still reading this. I've read about half of it. Superb, really very nicely written, etc. Very nice material. All of these books that I'm going to show you came out in the last 6 months or so. The second one is Aladdin's Lamp, over here, of which I read maybe 2-3 chapters. I haven't brought with me. And the third one, which is being sold over there, which I read because it's short and very easy. And Ihsan Masood is a common friend of us. Science and Islam, a History. Because Ihsan Masood actually ran a 3-part BBC radio series on Islam and science. It ran in March, just 4 months ago. So that tells you how much interest there is now in Islam and science. Books, TV series, radio series, etc. All of this in the past 6 months. Now, development of the Islamic civilization. Both Islam, the religion, and Arabic, the language, played a central role in shaping the appropriation and transmission of science in the culture. How did that take off? The way it took off is twofold. One, at some point, very early on, the Muslims realized that they had in their own religion certain needs. 5 prayer times daily that they had to know exactly what time did they occur, different locations, it changed by latitude, longitude, season, etc. Direction of prayer, to Makkah, I will explain all this in a second. The fasting of the month of Ramadan, the time of the pilgrimage. As I always tell people, 4 of the 5 so-called pillars of Islam all have to do with science. The 5th one being the profession of faith. I believe that there is no God but the one God, and that Muhammad is a messenger of God. Clearly that one could not have anything to do with science, but everything else, prayer, fasting, giving alms, charity, etc., all of that is related to science one way or another. And Arabic, the language, because it sort of unified people through the religious practice. People have to pray in Arabic, people have to read the Quran in Arabic, etc. So it helped shape the way the culture was appropriated and transmitted. Secondly, the second main factor was there was immediately an interaction with other peoples. From India at first, and from Persia, but immediately also from Byzantium, the Greek tradition, which it took 150 years to translate everything in sight. We have people who reported that they spent 10 years looking for one manuscript, going from city to city, from Isfahan to Cairo to Fez, etc. So all of this helped develop this Islamic civilization and culture. Translation of scientific works, as I just said. Sabra, again, the same specialist that I quoted earlier, says, the result of these early and unprecedented translation efforts over a period of roughly 150 years was that the Arabic language came to acquire a scientific legacy never before equaled in richness and variety, because people had to invent words, had to translate, had to modify, and so on and so forth. Examples of Arabic scientific vocabulary we still use today in the English language, in the Latin, Western world, etc., directly from Arabic. Alchemy, alcohol, algebra, algorithm, azimuth, zenith, Nader, and then some of the star names, Deneb, Altair, and many, many others. All of this is from Arabic, still in use today. Now, the special Islamic needs for science and astronomy, why science had to be developed for religious purposes. First, prayer times, as I mentioned. The prayer times are the early dawn time, so people had to know when was the moment when the first rays of the sun, which is still well below the horizon, when do they start reaching us? So there's a whole theory of refraction of light, and there's an atmosphere, and so on and so forth, and people are still debating to this day. Is it 18 degrees or 17 degrees below the horizon, etc.? The second one being the noon time. Noon is very easy, although there were some discussions as to, okay, so how do we define minimum shadow, etc. The third one being the mid-afternoon prayer. Still some discussions up to today. What do you mean by mid-afternoon? Is it the time when the shadow is really intermediate between what it is at noon and when the sun sets? Or is it really the intermediate time between noon, etc.? So there are some variety of discussions. Fourth one being the sunset. Sunset is easy. And the fifth one is when night sets. Now, what does it mean that night sets? Meaning that you do not see now anymore any ray being left from the setting of the sun. So again, some theory of astronomy and so forth. Direction of Mecca. People, of course, pray everywhere. All Muslims pray to the direction of Mecca, or the Kaaba, that famous black house in Mecca. And so people had to be able to determine from wherever they lived, where is the direction to Mecca. So of course, at the time, obviously, the New World was not known, but now we know that if you live, for example, in Miami, or better yet, if you live in New York, then you do not pray in this direction, that you pray like this, because it turns out that geodesically, etc., it's much shorter. In any case, knowing that the Earth is a sphere, and this was known, of course, for a long time. This was one of those myths that John Brooke referred to this morning. That people think now that for a long time people thought the Earth was flat, which is of course totally untrue. It was established that the Earth was a sphere in many different ways, from eclipses and so forth. In any case, knowing that this is a sphere, and knowing that you live here in Afghanistan, or you live here in Morocco, or you live here in Turkey, or wherever you live in Spain, which was Muslim for 7 centuries, what is the direction of Mecca? So this was a non-trivial problem. It's spherical geometry, spherical trigonometry even. The prayer times I've already mentioned. And then there are all the Ramadan issues. When does the month of Ramadan begin? This is what Dennis was asking me this morning. The definition is when you see the first crescent of the new period of the moon, seeing the first crescent, not when the moon has reached conjunction. So this, of course, opened the way for all kinds of models and arguments. When is the crescent going to be seen first? When the moon passes conjunction. And so there were all kinds of criteria. Some of them known as the Indian criterion, 48 minutes of lag time after the sun has set. And then some of them known as the Babylonian criteria, 12 degrees of separation, angular separation between the sun and the moon at the moment of first visibility, etc. And so the Muslims had to go back and understand all of this. Crescent-based months, calendars, because the Islamic calendar, for religious purposes at the very least, if not for civil purposes, is based on the crescent. Last but not least, there were non-astronomical, non-geographical issues that required the development of some science. For example, zakat is the obligatory tax, charity, whatever you call it, is the third pillar of Islam. People have to give, at the end of the year, some of their savings or earnings. So there's all kinds of rules to this. If it is just money, and you have saved some money in the bank, then you have to give 2.5% of your savings. If you have agricultural crops, then it is 5% or 10%, depending on whether it was watered naturally from rain or you had to bring water from somewhere, etc. So people had to know how to calculate all of these things. Inheritance is a complicated issue. In fact, as I will explain in a second, I don't know if I have all of that on the slides. Al-Khwarizmi, who is the very first great mathematician, who developed algebra. In fact, the word algebra comes from his book titled Al-Jabr wal-Muqabala, the restoring and the balancing, meaning of equations. So this is how he developed algebra. The very first example that he gives and shows to people how to go through it step by step in his book is, suppose a woman dies, and she leaves a husband and 3 children, 1 boy and 2 girls, knowing that the boy in the Islamic tradition takes twice as much as the girl, and the man takes 1/4 of whatever the fortune. How do we distribute it, and what is this? So he shows to people, okay, it's basically setting up an equation. Nowadays it would be high school math. But he tells them, okay, here's how you write this, this, and then you take this to the other side, and you divide and you multiply, and you get this. All of this, and he explains explicitly, is very useful for the rules of inheritance, for religious purposes. Medicine, obviously, architecture, because you had to develop certain styles or certain directions of the mosque. Where are the winds going to blow? Where is the sun going to be in the winter and in the summer? Knowing that, of course, we don't have always, the sun does not always rise in the east, as everybody knows, and the sun does not always set in the exact west, because there are variations depending on the inclination, on the latitude, etc., knowing that the earth is inclined compared to its to the vertical axis by 23.5 degrees. All kinds of issues like this that had to be developed. Anyway, now, Islamic, Arab, or Arabic science. First of all, contributors were from several different ethnicities and varied religious persuasions. When I put a 1 there, it means there's some reference given here. Including Jews, Christians, for example, Hunayn ibn Ishaq, very well-known translator and scientist, Sabians, Thabit ibn Qurra, etc. George Saliba, another expert of Arab origin but Christian, who works at Columbia, has written all kinds of books on Islamic science, wrote the following to illustrate this idea that there were all kinds of ethnicities and people. Some were Arabs, many were non-Arabs, some were Persians writing in Arabic, traveling in India, and so forth. He says, the Tusi couple, I'll come back to Tusi later. Tusi is one of the great astronomers of the late Islamic period. And the Tusi couple is some ingenious device that Tusi put together to try to remedy to the Ptolemaic system, which was found deficient. And so Tusi constructs something, and he says, okay, if we postulate that the planets rotate and revolve like this, then this will solve the problems. It didn't solve it completely, because we knew that in the end, you had to go to the heliocentric system. And so if you remain in the geocentric system, whatever ingenious system you constructed was not going to work. But anyway, the Tusi couple, by the way, the Tusi couple was adopted fully, completely by Copernicus. So that tells you how influential that was. The Tusi couple was written in Arabic by a man who spoke Persian at home and was working within and yet reforming classical Greek astronomy. His theorem was then translated into Byzantine Greek around the 14th century. Tusi was in the 13th century, and used later by Copernicus and others in Latin texts of Renaissance Europe. Then he says, what name could one possibly dream up for that kind of science, and whose science was it anyway? So would you call it Arabic, Islamic, Middle Eastern, Greek influenced, Ptolemaic? What do you call it? Now, institutions of science. First, there were the madrasas, which have acquired a bad name recently. Madrasa simply means school of religious law. And so the students basically are trained to become imams or religious scholars. And of course, it has acquired a bad name because madrasas have become so fundamentalist and have been sort of dominated by the Taliban and so forth, and they only exist practically nowadays as madrasas and called like this in Afghanistan and Pakistan. Anyway, but a long time ago, madrasa just meant school, religious school. Little emphasis on the learning of science in those schools, but teaching of religious law required non-trivial competence in mathematics and astronomy for the topics that I mentioned earlier, for being able to explain to people when are the prayer times determined, why do we pray in this direction and not in that direction, how do we know that next Saturday is going to be Ramadan or next Sunday, etc., etc. Secondly, there were some universities that were developed early on. They were not as comprehensive and as long-lasting as the universities that developed later in Europe, and I will mention that as one of the reasons why Europe emerged later, whereas the Islamic civilization declined. But universities were developed very early on. We still have today at least Al-Azhar in Egypt, available for visit. Anybody who goes to Cairo can visit Al-Azhar, more than 1,000 years old. But before that, the Nizamiya school or large school in present-day Iraq and Iran, Mustansiriya in Iraq, etc., and other universities associated with the great mosques in Damascus, in the great Umayyad Mosque of Damascus, Qayrawan in Tunisia, Fez. I was in Fez just a month ago or a month and a half ago, and these still exist today, but a long time ago they were real universities. Now they're basically little schools for children learning Quran or something like this. Houses of Wisdom, you remember that book that I referred to earlier. The House of Wisdom is Bayt al-Hikmah, a very well-known place that was developed by the Abbasid Caliphate in the 8th, 9th century. Originally it was just a library. The Caliph decided to have a large library where he could stock up all the knowledge that was being translated or brought over from somewhere. But then quickly they became houses of learning. They became centers of research, so to speak. So they were storage space for books, but meeting places also for scholars, for discussion, etc. Particularly that of Baghdad. This is the very first and the famous one. When you hear the House of Wisdom, this is the one in Baghdad. There's a little painting that sort of represents the House of Wisdom in Baghdad. You can see all the books being stacked over there. It is said that on the day it was opened, the Caliph gave of his own collection 80,000 books to the library just to sort of start it up, and later it became much larger. Institutions continued, observatories. Now this is very important. There were many observatories that were developed. Of course, remember that all of this is pre-telescope. So when we talk about observatories, we're talking about naked eye astronomy. We're talking about the usage of large sextants. We're talking about the usage of large astrolabes, armillaries, things like this. But still, they were large scientific astronomical institutions, often mixed in with astrology. Although we know that some of the scholars wrote in their books that we really don't believe this stuff, but the rulers want this, so we have to sell them this. But some others really didn't know what to make of astrology. So there was often this conflictual love-hate relationship between astronomy and astrology. But the point is, there were these observatories represented in beautiful paintings like this. Few survived intact when rulers changed. The problem is the next ruler says, I don't want this, why is this? And they would be told, this is for astrology, and astrology is against Islam because it predicts events, and nobody can predict events since only God knows the future. And so he would say, remove that heresy from here. So that observatory would be gone. Then there would be somebody else who would say, no, I learned that the astronomers or astrologers were able to predict the great battle, and so this is useful, so please give them more money to do this or that. The most important observatory is the one known as Maragha in today's Azerbaijan. In Azerbaijan, now in northwestern Iran, founded in the 13th century. Hosted some very surprising advancement in Ptolemaic astronomy, in particular Tusi that I mentioned briefly earlier. These are images of what remains today of the Maragha Observatory, these two over here. This is a drawing of how it looked like at the time, with these openings all being used for measurements, for measuring positions. Because astronomy at that time, of course, is not astronomy of today. There was no such thing as spectroscopy or spectrography. We didn't know. You couldn't tell the composition of this or that. All you could tell is the positions of different celestial objects, and therefore be able to construct planetary models. And so it was very important for them to know measurements very precisely. The next one is Samarkand. Samarkand is in Uzbekistan, founded in the 15th century. This is very important for the following reason. First of all, it shows that the development of such huge institutions went on until the 15th and sometimes the 16th century. So the decline, which is usually considered to have started around the 11th, 12th century, cannot be accepted as such, because we know for certain that certain institutions were developed much later than that. Secondly, the Samarkand Observatory had a sextant that was dug in the ground 200 meters of length. So huge. The reason why it had to be huge, of course, is because they wanted to make very, very precise measurements, so that when you see the light of some star or the moon or whatever falling somewhere, you can measure it to the arc minute and not to the degree. So that tells you how big these things were and how important they were. Istanbul Observatory, even later. The Istanbul Observatory was erected in 1577 and was destroyed. Bim means built, not born, and di means destroyed, not died. Destroyed in 1580, so only 3 years. This is very unfortunate that this observatory was destroyed so soon after this, because those of you who know some history of science or history of astronomy will recall that 1543 was the publication of Copernicus's book. And so if this observatory had lasted for another 20, 30 years, then we would have had a long discussion of the Copernican revolution, which unfortunately did not take place. These are drawings of the Istanbul Observatory with the armillary here in the middle, and some scholars sitting here and arguing, discussing whatever. Some more images. This is supposed to be Tusi himself at the Maraha Observatory, with maybe some students or some scholars discussing things with him. This could be an astrolabe or could be a celestial globe. We can't tell if it's three-dimensional or if it is flat. So either way. And here sort of the decoration in the ceiling representing constellations and stars and things like this. This is a book not related to any of this, but just for illustration purposes. This is a book. This is Euclid's Elements, translated by Tusi. So that tells you, this is Tusi, the same guy, 13th century. This is his own version of the translation of Euclid's Elements into Arabic. This is a copy, this is a beautiful thing. This is 2 pages from a book written by Abdurrahman as-Sufi in the 10th century, representing the 48 constellations as they were known at the time. Not only do you have all the tables and the numbers and everything shown here, but this is the first time that there is a book of science or knowledge in the Islamic tradition where full drawings, full paintings in color, including of live people or animals, etc., are shown. Anybody can tell who these two are? The twins?
Castor and Pollux.
Yeah. Gemini. Gemini. Curators of the Museum of Greek Science, question mark. Were they curators really? Did they just preserve as it is often presented, or did they really contribute something significant? Very quickly, as I mentioned, I think now there is no question that the initial creation and development of algebra was done by Al-Khwarizmi. We have the books, etc. Revolutionized optics, theory and applications from Ibn al-Haytham in the early 11th century onwards. It is said, I don't know how true this is, that a student of Descartes had gone to the Arab Islamic world and read some of the books of Ibn al-Haytham, and I don't know if he carried a copy of the book or just had his knowledge and passed on the information to Descartes, who used it or took it into account in doing his physics. Constructed sophisticated astronomical instruments, sundials, armillary spheres, astrolabes, quadrants, sextants, etc. Developed trigonometry. We now know for sure that the sine, the function of sine, opposite to hypotenuse, was brought in from India with the Siddhanta, when a large delegation from India came to visit the Abbasid Caliph, and he was just stunned at the knowledge that they had, and so he said, he ordered that their books be translated right away, and that anything that can be brought in and translated will be paid very handsomely. So the Muslim mathematicians took that, synthesized it with the Greek chord, and developed trigonometry. So the tangent, the cosine, etc. were developed by the Muslim mathematicians. Extended number theory to include irrational ones. Again, same process. The Arabic, what is known today as the Arab numerals or Arabic numerals, what we use nowadays. We don't have any on this page, but you'll find them in a second. All those were taken from India. Were taken from India. Al-Khwarizmi wrote a book on that, showing the usefulness of using that, including the zero, and how that was going to be so much more efficient in doing calculations, etc. But they extend it, so it's always the same idea. It's they take science or some knowledge and then they develop it and they add to it and they extend it. Solved higher than quadratic equations, including Al-Khayyam. Many of you will know Al-Khayyam, one of the most popular Persian poets, the Rubaiyat Al-Khayyam, the quatrains of Al-Khayyam. Al-Khayyam was a poet, mostly known for his poetry, but also a great mathematician. Developed what, until I think the Renaissance, was the most sophisticated calendar ever put together, lunar-solar combination. Anyway, and he solved third degree, fourth degree equations, of course not with symbols as we do today, but with geometrical approaches, and take this ellipse, cut it with this plane like this, and then the line would go like this, and that's how they did. Further developed the ideas of John Philoponus. John Philoponus was a theologian of the 6th century in Alexandria, but also to some extent a physicist, we might call, because he developed some ideas, what we now call the impetus theory, which is an alternative to Aristotle's theory of natural motion. This is the premise, this is the beginning of revising the Aristotelian physics. In fact, that whole correspondence that I referred to earlier between Al-Biruni, whom I consider as probably the most sophisticated, highest standard, even though he only lived in the 11th century, scientist of the Islamic civilization, had long correspondence with Avicenna because he had serious doubts and troubles with the Aristotelian physics. And so he would, for example, one of the questions that he asked Avicenna, he would say, why does Aristotle reject elliptical orbits? Think about it. Why does he reject elliptical orbits? Avicenna starts saying, because if it is elliptical, it would imply necessarily that there would be vacuum in certain places of space, and vacuum we cannot accept. We know for certain that we cannot have vacuum. Things like this. So it's really physics being discussed. In any case, nobody, of course, developed inertia. Nobody, of course, developed the concept of mass, let alone the concept of force and concept of acceleration that we now know from classical physics. But they started to look at Aristotle's physics and really criticize it. Now, the decline of Islamic science, let me mention some causes, what I consider as probable important causes, and you may think of some additional ones. Institutional isolation. First of all, the institutions themselves were not solidly structured. It wasn't clear how a house of wisdom or a house of learning or a university functioned really, how it admitted students, how they graduated, what was the curriculum, etc. It was like, okay, let's put there, and then there's this big scientist, so we'll make him director, and then he will have his own program, so you put some students to work on this, and then he dies, and somebody else goes like this. So the institutional basis of the learning and the scholarship was not very solid. Secondly, there was wide geographical extent. It was spread from really the borders of China. And yesterday at dinner we were discussing the exchanges with the Chinese empire, between the Chinese empire and the Islamic empire, all the way to Spain, which, as I said, remained under, at least partially, under Muslim rule for 7 centuries. And it was difficult and slow to communicate between all these scholars. Secondly, political and social instability. There were sometimes brothers killing each other over, some throne. There were factional and sometimes even religious infight. This group against that group, there were external threats, it is widely considered that the decline, very often people refer to the date when the Islamic civilization started to decline by the takeover of Baghdad by the Mongols, the Mongol invasion. The Mongols later all converted to Islam and their empire became a Muslim empire. But at that time when they invaded Baghdad, everything was destroyed. All the books were thrown into the rivers, tens of thousands, if not hundreds of thousands of people were massacred. It was just total destruction and annihilation of anything resembling learning. So people always refer to that moment as being the moment of just break. But as I mentioned earlier, we know that in other places, in Persia, in Turkey, etc., it continued until the 15th, 16th century. Dangers and losses. It was very dangerous to just live in those times. Al-Farabi, who is considered as one of the maybe 4 or 5 greatest philosophers of the Islamic tradition, was killed on the road by some thugs who wanted his money. So, political and social instability. Intellectual fragmentation or integration, this is the one that I have the most trouble with, because I read people and they go in 2 diametrically opposed directions on this. Some say Islamic science was slowed by its too weak ties to philosophy. Say, no, it's because they didn't have the whole integration of the science and the philosophy, the worldview, etc. And some say, no, it was too much philosophy. Science was all philosophy, and so it never developed what we were discussing this morning, methodology, naturalism, things like this. And that is why science in the Islamic world remains sort of, old, ancient science. It never crossed into modern science. Was Islamic science too much or too little integrated as a worldview? I am really asking this as a question. I don't know. Further causes of decline, the rise of Europe. I always tell people that really it wasn't the decline of the Islamic civilization. If there is one element that I would pick over all others, it would be this one. It's just that Europe rose. It rose for very important factors, including the emergence of universities, the invention of the printing press, the age of discovery, going to discover the Americas and going around the southern tip of Africa and going to India and opening trade routes. And that age of discovery was associated with prosperity. All of a sudden there were huge amounts of goods and money and trade and so forth, and the Islamic world was sort of forgotten. No need for the Islamic world. That world started to decline for that reason. And then finally, decline when? Okay, we agree that there was some decline. Clearly, when you compare what was being done 1,000 years ago to what was being done 200 years ago, or what is being done nowadays, a huge difference. So there is decline. But decline when? Usually said to largely decline by the 12th century, 13th century, but Istanbul Observatory was built in 1577. Arabic science remained vigorous into the 18th century, as we now know, because we have found some manuscripts that people, including here in England and in Europe, were exchanging in Arabic. So people still found some knowledge and some useful material in Arabic up to the 18th century. So there was some exchanges up to that time. Between European and Ottoman scientists continued up through the generation of Newton. Now I want to move on, I have maybe 15 minutes left or so. I want to move on to the more conceptual issues. This is what I will be addressing more thoroughly tomorrow, but I want to look at these questions now in that context of the old Islamic civilization and how things were developed at that time. First, let's look at how science/knowledge. The reason why I put science/knowledge is because the word for it in Arabic is the same. And that opens up a whole line of discussion as to when you use the word ilm, which you will see written a couple of times in the next slides. Is this referring to knowledge or is this referring to science? Big difference, of course. Now, no, science is not just any knowledge. But, in any case, what is being said about the pursuit of knowledge, the pursuit of worldly, natural knowledge, science, in the Quran, for example? It says, and among his signs is the creation of the heavens and the earth and the variations in your languages and your colors. Verily in that are signs for people of knowledge. So people of knowledge are being hailed. Say, consider what is in the heavens and the earth. Say, travel in the land and see how he originated creation. Although in another translation of the same verse, it can be translated as, say, travel in the land and see how creation begun. Not necessarily he originated. It's sort of added in the interpretation. So some people say, you see, it says that creation started somehow. Not necessarily that he originated it or started it. In any case. But the emphasis here is travel in the land and see, meaning go and observe and measure and do science or do learning. He who created everything and ordered it in exact measure. People often refer to this verse to say there is order, and we'll be hearing tomorrow some talks about how religion, Christianity, the Bible, Islam, etc. were instrumental in developing modern science from that concept of order in the universe. Even Roger Trigg referred to this morning and said, you have to believe in science that there is order, otherwise you cannot do science. So this is clearly stated in there. Not only is there order, but it is in exact measure, meaning it is well organized. So go and find out. Some more now on the Prophet's statements, usually referred to as Sunnah. The ink of the scholar is more sacred than the blood of the martyr. I like to repeat this to my students and my co-religionists, especially these days. Seek knowledge even in China. And this is important because people in the Islamic culture say, yeah, but this science and this knowledge and this whatever is being referred to in these scriptures is really religious knowledge. And so we bring up this prophetic statement and say, clearly there was no Islamic knowledge to be gained in China, that the Prophet would send people to, or encourage people to go to China. And clearly he was referring to more diverse knowledge. An hour's contemplation or study of nature is better than a year's adoration of God. And if this is not an encouragement to science, I don't know what is. God put out there a cure for every disease he created, meaning go and find it. Go find the cure, not the disease, or find both. The concept of ilm, again, this same idea, knowledge, science in Islam. I'm beginning to make sort of the transition to the modern times. Ziauddin Sardar, who lives in the suburb of London, has insisted on the moral dimension of ilm, this knowledge or science in Islam. He writes, I'm sorry that sometimes the slides have a lot of writing, but because I quote people, and some of the citations are important. The concept of ilm, knowledge or science, integrates, in Islam meaning, integrates the pursuit of knowledge with values, combines factual insight with metaphysical concerns, and promotes an outlook of balance and genuine synthesis. Meaning science and knowledge in Islam must not be dissociated from the values attached to it. This is knowledge or methodology coupled with ethics at the same time. And they say it is intrinsic to the concept itself. He adds, this is still Sardar, this concept shaped the Muslim mode of thought and inquiry and shaped the main features of Muslim civilization. It is because of this coupling that the Islamic civilization took on the features that it took. Likewise, Munawwar Anis, another contemporary thinker, declares the concept of ilm to be one of the most sophisticated, all-comprehensive and profound notions to be found in the Quran, one that is, in its significance, second only to Tawheed, Tawheed meaning the unification of God, or believing in the absolute oneness of God. So after the absolute oneness of God, according to Munawwar Anis, the next most important concept in the whole Islamic culture is this concept of ilm, which is science and ethics combined at the same time. Knowledge in the Quran, Golshani, who has visited here in recent times, and other contemporary thinkers, claim that the Quran and thus Islam does not distinguish between different forms of knowledge. Now, this is important because, as I said, some religious thinkers in particular insist that all of that stuff that I mentioned only applies to religious knowledge. But Golshani says, no. Ilm, knowledge, science encompasses natural science, social science, religious science, any other science. They're all combined in this concept. Indeed, knowledge in Islam has a holistic nature. He writes, this is Golshani, Muslim scholars during the Golden Era considered the scientific branches as continuations of the religious quest. So when you do biology, or you do geology, or you do astronomy, you are continuing your religious search for truth. Islamic art played a similar role, for it, like the sciences of Muslims, aimed at exhibiting the unicity of God's plan in the universe. So it's all holistically combined. Sardar concurs. He insists on another aspect of the Islamic civilization. He says, in the Islamic civilizations, people who emerged were polymaths. And so he gives some examples. Al-Biruni, that I mentioned before, Al-Jahid, known for his writing, but also for his knowledge of zoology. He has a whole book, probably his most famous book is the Book of Animal, a whole encyclopedia of animals and how they travel and where they go and how they mate and how they develop. Some people even found some hints to evolution in that book. Anyway, Sardar mentions Al-Biruni, Al-Jahiz, and 10 others he mentions by name that I removed from here because it would be too long. And thousands of other scholars are not an exception but the general rule in Muslim civilization. So the idea here is that science knowledge in the Islamic civilization is holistic, that people do not specialize, they do not become mathematician and that's it, or astronomer and that's it. They're always multi-dimensional scholars. On the other hand, because we have to be fair and we have to be objective, there were objections to natural science from some important scholars. Muslim scholars were not all fully embracing of all knowledge and sciences. Many adopted a carefully selective stand. They would say, okay, this science, okay, fine. This one, no, forbidden. Do not go there. So there was this debate. Al-Ghazali in particular, Al-Ghazali is probably the theologian of the 11th century, probably the most important theologian of the whole history of Islam, still largely influential today, and although he was rebutted and there's all kinds of discussions after him about his views, but in any case hugely influential. Al-Ghazali in particular declared that natural sciences are a mixture of truth and falsehood, correctness and errors, and that mathematics had to be avoided because it was often the preliminary and foundational science to, quote, erroneous sciences. He wrote, we forbid, this is an exact quote from Al-Ghazali, we forbid the study of the science of Euclid and Ptolemy, which are the details of calculation and geometry. Although it makes the mind and the spirit stronger, he realizes that, it's, as I tell the students, if you do Sudoku, it's good for you. So it's math, juggling your mind, etc., and looking at the sky and understanding. He realizes it makes the mind and the spirit stronger for what it leads to. Indeed, it is he says, we forbid the study of these for what they lead to. Not in themselves, but for what they lead to. Indeed, it is the preliminary to the sciences of the ancients, which contain wrong and harmful creeds. He says, if you follow that path, if you start with math, you will go to astronomy, then you will go to the cosmology, and then you will start believing that the universe has always existed here, or that there are many gods, and then we get into all kinds of trouble. Other conservative scholars have expressed more hostility toward non-religious sciences. Ibn Taymiyyah, usually referred to as the big reference to fundamentalism and Wahhabism today, has written, only the knowledge inherited from the Prophet deserves to be called science. Anything else can either be a non-beneficial science or a so-called science. And in both cases, if there was any good in it, then one would find it in the Prophet's tradition. Case closed. So there were some thinkers, not scientists. This debate goes on to some extent today. And we'll see that again tomorrow as to how is science related to Islam and philosophy and modern science and methodological naturalism and all of this. Summary. I'm just about at my time. I told you at the beginning that there was current renewed interest in the history of Arabic Islamic science. Arabic science because it was all done in Arabic, or all written in Arabic, or 95% of it was all written in Arabic. Islamic because it encompassed the whole Islamic territory. Arabic Islamic because it was a mixture of people from all places. There are special Islamic needs for science, especially in astronomy, as I mentioned. and that helped develop science. There were some important Islamic scientific accomplishments, therefore they were not curators of the Museum of Greek Science. There were different institutions of science, madrasas, universities, houses of wisdom, quote unquote, observatories, etc. This is how the science was done then. I mentioned some of the causes for the decline of Islamic science, and the debate and the discussion regarding when it declined, why it declined, how it could be restarted, etc., is one of the current topics of large discussion and debate. I also mentioned at the end some of the conceptual issues regarding knowledge/science in Islam and the Quran, the pros and cons. As I mentioned, we can find a lot of statements that encourage people to seek knowledge and science and go travel in the land and try to understand this and that and so forth. But you can find also some scholars who warn and forbid and don't want to be influenced by, then it was Greek, Babylonian, Indian thought. Nowadays it could be Western science. I'll stop here. Thank you.
Thank you very much, Nidhal, for that fantastic overview. So I'm sure that's raised plenty of questions. Yes, Erlen.
I wonder if you'd elaborate just a little bit more on the reactions to Al-Ghazali, and specifically for Averroes.
Yeah.
What happened to him?
Yeah. Thank you for the opportunity. Yeah, the question is if I could elaborate a little bit on the reaction to Al-Ghazali, this great theologian who remains very influential today, and Erlen is mentioning in particular Averroes, who wrote, as I will say in a moment, the big response to Al-Ghazali. Al-Ghazali in the 11th century wrote the book that is sometimes referred to as the one that killed philosophy and science and learning in the Islamic world. It's called Tahafut al-Falasifa, the incoherence of the philosophers. The first chapter of which is known as Maqasid al-Falasifa, the objectives of the philosophers. So he takes the Hellenistic philosophers of Islam, Al-Farabi, Avicenna, Al-Kindi, and he quotes their views one by one. He says, okay, before we address them, we need to understand what they say. And then he spends 20 chapters, issue by issue, refuting them, in three of which he concludes that on this issue, not only are they wrong, these so-called Muslim philosophers, they have crossed the line of heresy. And so he declares them as heretical. And that book was so stunning that people just read it and said, okay, this is the last word on it. It took about a century later for somebody to appear on the other end of the Islamic empire. Abu al-Walid ibn Rushd, as he is known in the Arab world, Averroes in the West, wrote Tahafut at-Tahafut, the incoherence of the incoherence. The incoherence of the incoherence of Al-Ghazali. And it was paragraph by paragraph. I mean, he quotes him and rebuts, quotes him and rebuts, quotes him and rebuts. Not only does he rebut, but he shows him that basically you have not understood Hellenistic philosophy. You have not understood Aristotle. And the reason why you have not understood Aristotle is because you have relied on Avicenna, and Avicenna himself has not understood Aristotle properly. So he says, okay, here's what Aristotle really says. You have to remember that Averroes is known in the West as the great commentator, the one who wrote the great commentary on Aristotle. Somebody who knows Aristotle, backward, forward. And so he says, okay, now I'll tell you what Aristotle really said, what he meant, and here's why it does not clash with Islam. In another follow-up book known as the Definitive Discourse on the Harmony Between Philosophy and Religion, Averroes shows, very beautiful little book, he shows how Greek philosophy, and today I say, I take Averroes as my model, an idol, I said exactly the same arguments and the same methodology can be applied for modern science. And he shows why they cannot be, or we can easily construct a non-conflictual relation between the two. Unfortunately, this is history. Averroes was much more influential in Europe, was almost totally forgotten in the Islamic world. And only in the 20th century have we started to go back to his books and to really understand his methodology and realize how it can really help find a harmonious relationship instead of relying on such views as I quoted from Al-Azhar.
Yes, please. Yes.
First, I have a detailed question. I'm very intrigued why the Istanbul Observatory was so quickly destroyed after 3 years.
Yeah.
And then secondly, do you see in this very intriguing rise and decline of Islamic culture some kind of evolution in the science and philosophy and theology in articulation? Like, for example, in Europe, you see that the universities are originally church initiated, and then progressively philosophy and science work out from this domination, because you give a lot of elements of the decline which are rather material, political, economical. But is there a link with some conceptual evolution, or in one way or another?
Yeah, thank you. Should I repeat the question?
I think probably, but if you couldn't hear that, wave your arm, but I think people could hear that.
Okay. On the first question, I sort of mentioned the reasons for the Istanbul destruction, but it was quickly in passing, and I maybe did not make it very clear that it applied to that case. It was regarding, when I said some rulers sometimes died and were replaced by other rulers, and the new rulers would have different inclinations or different religious profile. And they would be more inclined to support something that is presented to them as real science as opposed to astrology, or perhaps the other way around. If they are told, you know, this can help tell you when will be the best time to go invade this place instead of the other way, or to build a city. We know, for example, that the building of Baghdad, which in 20 years became the second largest city in the world after Constantinople, the place and time was decided by astrologers. So it tells you how some rulers really looked at science. So what happened in Istanbul was the new ruler came and was told that this is astrology and this is against Islam and prediction, etc. And he said, remove that, which is, like I said, very unfortunate. The second question is a very important question that you raise. Indeed, I am sometimes, this is not the first time that I am criticized for not bringing such conceptual. I mean, criticized, critiqued, you know, debated. I don't mean in a negative way, on the contrary. That I tend to sort of look at, as you said, materialistic reasons on the ground, what happened in history, etc. But some people have referred, for example, to Al-Ghazali, and people say, why don't you mention Al-Ghazali in the causes of decline when you list your causes of decline, or, you know, the orthodox thinkers and how they sort of froze the development of knowledge and science. What my reaction is, there is some truth to that. There is no question. I cannot neglect it altogether. That the conceptual issues played a part, and I will get back to that in a second. But at the same time, we cannot say that there was fast rise and fast decline of the Islamic civilization. It took about 150 to 200 years for it to really reach the level of now scholars are contributing and books and exchanges and so forth. And then, as I said, the decline, when do you start the decline? Some people started in the 12th, 13th century, and we can see that there is still some progress going on up until the 16th century at the very least. So there was decline, there's no question, but it seems to me that this decline was very shallow. I mean, slope was like this instead of like this. Conceptual, you are right. I mean, at some point, and this is what I tried to say this morning, at some point, methodological naturalism took over and triumphed very quickly. And this clearly did not happen in the Islamic civilization. This occurred in the West. Why methodological naturalism did not occur in the West? Maybe because Al-Ghazali said, be very careful with these philosophers, and developed his, I didn't have time to explain, the occasionalism concepts, etc. How is the concept of natural law, divine action, when in the example of Al-Ghazali, when cotton is burned, this is the example he uses, Is it because this element is being mixed with flame and there is, of course oxygen was not known at that time, something that favors this burning? Or is it because God says burn? And he says, no, it's because God says burn. And now, so why is it that every time you put cotton with some flame, it burns? He says, because this is God's habit. This is the way God works. But sometimes he will decide that I'm going to change my habit, and he will change it. So methodological naturalism could have appeared in the Islamic world if the philosophers had dominated. It could not have developed in the Islamic world as long as theologians who insisted on divine action, miracles, intervention, and so forth to remain a possibility. So we could go on.
Well, we're still on the decline of. It is a fascinating topic. I mean, but still, while we're on the topic of the decline of Islamic science, it seems to me often the different reasons. It's very difficult to sort of match up the dates, isn't it? Now, I think Essam Massoud in his book points out that, in fact, after the fall of Baghdad, many of the great Islamic discoveries in science were in the century after that. You know, he has a number of examples. Mm-hmm. So actually, although that may have been a factor, actually, you know, it doesn't seem to have finished it off, that's for sure, because there's still plenty of very famous, you know, names in Islamic science after that time. And then coming from the sort of other direction, the kind of colonial replacement theory, or, you know, the effect of colonial science, again, the dates, to me, don't always seem to match up very well. If you actually look at the pattern of transmission of colonial science, if you want to call it that, or European science around the world, it doesn't necessarily seem to be going up as the two graphs don't seem to be matching up very well. So I don't know if you want to comment on that, or the whole dating question again, you know. But
on the first part, it's definitely true, of course. Some of the examples, some of the striking examples, one of them I mentioned, Al-Tusi, with his Al-Tusi couple, which became sort of the most sophisticated astronomical planetary model of the time. Made it all the way to Copernicus. We know. I mean, it's the diagram. It's almost like copied by hand, is in Copernicus's book. Another great astronomer in Damascus, Ibn al-Shatir, in the 13th or 14th century, late 13th century, I think, also developed some planetary geometrical arrangements that we find almost verbatim in Copernicus, at least for the Moon and Mercury, and I think probably for Venus also. So clearly, not only was there some science that took place after Baghdad had been destroyed, but it was such good science that it was being used by Renaissance scientists. The colonial period, it depends which colonial period we're talking about and which region. The British, made it to India much earlier than the French and the Italians made it to North Africa. In North Africa, there was absolutely no transmission of knowledge whatsoever. No science that came from Europe to Algeria, where I'm from, or Tunisia or Morocco, or the Italians to Libya. But on the other hand, the British, not because I'm in England or because you're my friends, did much better. For example, in Egypt, we know that there was some schools, you know, the Anglo-Egyptian school or something. There were some developments. There was also that important episode of the Napoleon, what's it called, mission or voyage to Egypt, where he carried the printing press and took with him, you know, an army of scholars, and he wanted to both study the place and see whatever he could learn from it, from the Pharaonic and Islamic traditions, but also to pass on some knowledge. But there was a clash over there, although there was some influence. So I think it's very complicated to look at the 18th, 19th century period of now reverse transmission or reverse transfer of knowledge, institutions, etc. I don't know how that affected, but by that time, the Islamic civilization and the Islamic development of almost any type of knowledge had practically disappeared.
Thank you. questions. Yes, please.
Was there any Chinese influence? You mentioned that China was looked upon as like a remote place that nothing came from, but there must have been a great deal of development in China, which is relatively close to your part of the world, to Arabic.
The one major example, the one that we were talking about at dinner yesterday evening, is paper. It's the technology of paper. That definitely came from China, and came from China very early on, 8th century, 9th century AD, to the Islamic world. There are all kinds of stories as to how that came about, etc. But the point is, it was such a revolutionary transfer of knowledge, of technology, because it made the spreading of books, the readership of books, so widespread. It made it so much cheaper to produce books, even though they had to be copied by hand, and to sell them. And so many more people were able to read books, and therefore, if they had enough intelligence and enough time, etc., to become budding scholars. That was an extremely influential, very early transfer, which truly gave a big impulse to the Islamic civilization. That came from China, for certain. I can't recall right now, off the top of my head, any other important transmissions from China. There were some other, in the other direction, there were some transfers of knowledge, for certain. Astronomy, for example, there was a lot of transfer of astronomy. We were in Beijing, when was it? A year ago or less. There was this discussion about how astronomy, in particular, this year being the 400th anniversary of the invention of the telescope, this is 2009 is the International Year of Astronomy, etc. So there were these discussions as to how astronomy revolutionized people's thinking, etc., after the telescope and before the telescope. And there was a lot of discussion about how the Chinese rulers were calling on the Muslim scholars to come and show them their calendars. There was a whole issue about how to compute calendars for the Chinese years, etc., how to predict eclipses and predict the risings of the moon and things like this. So for astronomy, at least, the transfer was in that direction. I seem to recall that there were some other technical or technological ideas that were transferred back and forth, but I can't remember what exactly now.
Again, I don't know when gunpowder came over. When did gunpowder get? Because that came from China, didn't it?
Yeah, that came from China.
But I don't know the date. So
but that was not used in the Islamic world. That somehow seems to have gone directly to Europe.
Straight to colonialists.
Yeah, unfortunately.
Okay, yeah.
Your description,
yeah, go on, yes.
Your description of the opposition within some theological sectors of Islam to the advances of science and to the endeavor of science actually parallels my own current conservative evangelical community to a degree, based on our interpretation of certain biblical passages, particularly Genesis and Joshua and other portions of Scripture. Historically, there's been opposition to declarations that science has made, and of course, those claims today would be called, broadly absurd, frankly. Could you elaborate on maybe some of the specific sorts of arguments that those conservative theologians had, and maybe Quranic arguments that?
There were three major issues that Al-Ghazali, who is the big leader, brought up against the philosophers and declared them heretics on the basis of. Two of them, at least, have something to do with science or nature or understanding of the world. The third one, not so much, but I'll tell you. The first one was the eternity of the world. The philosophers argued for the eternity of the world, basically because they were convinced by Aristotle's philosophical arguments, period. I mean, of course, at that time there was no knowledge. I mean, there's no solid knowledge. There was no microwave background radiation. There was no nuclear abundances. No, I mean, how could you know that there was a starting point, what we call Big Bang now, with developing the whole theory or that the universe existed for a long, long time. Up until the early 20th century, it sort of seemed like the universe was static and eternal, and people accepted it because that's what the old philosophers, the great thinkers thought, and the great thinkers are smarter than anybody, so who am I to go and reject their views? But Al-Ghazali, reading from the scriptures and understanding the idea of creation as being God at some point deciding something. Yeah, and he would say, how could God have created the world an infinitely long time ago? And how could you have something that is infinitely old alongside God who is infinitely old? This goes against the oneness and the transcendence and so forth of God. So this is one issue. Clearly a scientific issue. But at the time it was a philosophical issue. And so he declared them to be wrong, and we now know that he was wrong, for certain. But not because his arguments were wrong, but because the science of the day did not permit one way or the other. What Ernan, for example, in some of his writings has called the, not duplicity, what do you call it in science when we have more than, the degeneracy of solutions. When you have more than one solution to a set of data. In that situation, we had a degeneracy of solutions. All of them could be right. Nobody should have called the other wrong, let alone heretical. The other issue was God's action and intervention in the world. The philosophers, again, turned out to be more correct, even though they didn't have the science to back it up. They argued for the laws of nature, and that you had to allow for some naturalism. And you could not just have God, here, here, here at every instant, sort of a puppet master everywhere in the world, fixing things and intervening. And this guy wants, and this has prayed, and this is falling, so I'll stop it. They said, I have to stop this nonsense. This is exactly what this morning we were saying. I mean, it becomes laughable. But Al-Ghazali saw that if you allowed that, then at some point you get to this naturalism. And at some point you have to go to what John called this morning deism, that God sort of backs off. And they said, no, this cannot be. So clearly this is physics, and this is a worldview, this is a conception of nature. How does nature function? And that's why I said earlier, if the philosophers had dominated, then methodological naturalism would have emerged in the Islamic world, and then of course modern science would have developed much earlier. The third issue was the resurrection of the bodies after death. The philosophers were saying this has nothing to do, of course, with science or with physics. The philosophers were saying, when we die, okay, we accept that there's going to be a day of judgment. We accept that we're going to be resurrected and tried, and that there's going to be an afterlife. But all of this has got to be metaphorical, symbolic, and it has to be in another dimension. You cannot be serious and think that I'm going to be raised as I am, with a little bit of white hair here, and I'm exaggerating, but they were saying it can't be like this. The resurrection cannot be physical, to put it simply. And Al-Ghazali said, no, what are you talking about? There are clear scriptural statements that say that we're going to be resurrected and we're going to be burned and burned. What do you mean burned? Burn means in the flames, and there are flame descriptions in the Quran and in the Sunnah and so on and so forth. So it went like that. So some issues were clearly natural issues, not to say scientific issues, but some others were a little bit more metaphysical.
Just around the back of that point, I think also is the parallelism with the hyper sort of literalistic interpretation of Quranic text. You may be coming on to that tomorrow, possibly. I don't know.
Yes, I will mention that tomorrow.
Okay, so
we might leave it.
Leave that for tomorrow. Yes, please. Thank you.
Just on the same thing, Dennis. Exactly. I just want to comment, but surely, in a simplistic way, that's the lesson. Surely the lesson is because Christianity was liberalized enough to have the Protestant Reformation, to have the whole. Let's say because it was less intransigent. Science found its voice eventually with great difficulty. It was allowed to flourish because, whatever about science without religion being blind, if you have science dominated by a religious perspective, in other words, you've decided what you're going to find out before you go looking for it, science simply can't survive that. And that's what really happened, that if the philosophers and the scientists weren't allowed in the Islamic world at one stage to freely express what they really thought, or if it was simply publicly contradicted. That seems to me to be the difference between the two worlds, that basically science really did go into serious decline because of that, and that didn't happen in the Christian world, although it very nearly did. It didn't actually happen. Or is that too simple?
I think it's a little bit too black and white. Let's back off a little bit. First of all, we cannot say that the philosophers and the scientists in the Islamic world were not allowed to express themselves or promote certain viewpoints. As I said, they said all kinds of things before Al-Ghazali, and it's true that in the century that followed Al-Ghazali it was sort of all muted, but then it took off again, or at least with Averroes. There was a whole school, it wasn't just Averroes. Ibn Tufail, Ibn Bajjah, etc. in Andalusia, in Spain. So for a long, long time, and by the way, nobody was ever burned in the Islamic world. Nobody was ever persecuted, and there were so many astrologers, and they were making all kinds of predictions. Nobody said, this is heretical, you die. So it wasn't like that. It was arguments, it was theological, philosophical, scholarly, etc. But there was no persecution, and people were allowed to write. You will be amazed what people wrote during all those centuries. This is one. Two, I think tomorrow morning we'll be discussing, perhaps even this afternoon, with Dr. Chapman, medieval cosmology and the church, and tomorrow morning the role of religion, scripture, the Bible, etc. in the development of modern science. I don't think it is that simple to say that at a certain point the church said, okay, you guys can do your science, and then everybody went on happily. I don't think it went like that. I think even the Protestant Reformation and Revolution was not immediately so pro-science, and so, I mean, you can see even in the States, nowadays. In fact, as I think John Brooke sort of referred to in passing this morning, he said that the church seems to have been more pro-science in the past few centuries after the Galileo affair that you pointed out than other branches of Christianity. So it's a mixed history. It's a mixed history. It really depends, case by case almost, depends on which period you're talking about, what case, etc. And there were many other factors, social factors, economic factors, things that were allowed because they brought in a lot of prosperity, or because they didn't bother the ruler, or certain other cases because this guy happens to be under the patronage of the other, so I'm going to kick him out and not allow him, or burn his books. All kinds of situations like this.
Ben, do you want to come to that?
Yeah, just to back up what you're saying there, I think there's a very interesting parallel here. When Averroes Ibn Rushd's ideas were taken up in the early 13th century in the West, one of their main developers was Thomas Aquinas. And Thomas Aquinas ran into a great deal of difficulty, specifically with the notion of eternity of the universe, the notion of the nature of Aristotelian science, which seemed deterministic, the other point you made. And what actually happens is that three months to the day from his death, part of his views are condemned by the church. Fortunately, he was canonized later on, which, and since saints can't be heretics, they had to withdraw those condemnations. But one reason, I think this ties in very much with something else you said. One reason why the condemnations, the famous condemnations of 1277, one reason that they didn't stand up, so to speak, was that there was a huge reaction against them within the university system. What allowed them to develop over the next 100 years was the nominalist presence within the universities, which was strongly anti-Aristotelian and which challenged, essentially they were on Averroes' side, and in fact they were to some extent criticized for being too Averroistic. So the whole Averroistic thing right up to the 16th century, right up to the Reformation, that what protected it were institutions that didn't exist, unfortunately, in Islam at that time. So it's very interesting to see the parallels and to see the role that Islam played in that. Averroes was a very important figure, as you said earlier.
Yeah, thank you.
Okay, I think we'll go there and then to the back. Yes, well, but if it's
Do you have a
brief, yes.
Do you have a perspective on how Darwin's theories were received in the Islamic world?
can we talk about this tomorrow? Because that is the 19th, 20th century, and I do have quite a few things to say. But because time is short and because it sort of fits with tomorrow, so we can talk about that tomorrow. Remind me if I forget.
General, the last question.
I am very interested about this point you brought. You brought really new insight for me about the issue that the root probably of big misunderstandings, I mean everywhere, also in Christianity, is not so much a literal interpretation of Scripture, but a sort of a physical interpretation of God's action. This is for me a very relevant point, because I have exactly the same problem, but I was not able to articulate this in the way we have done today. I have the same problem with many Christian theologians right today. That is, they interpret God's action as a sort of competition with natural causes. And I suppose that the Catholic tradition tried, probably not in a complete successful way, to deal with this issue when Aquinas, for instance, distinguished between primary causes, secondary causes. So it is for me very, very important to understand the root of this problem in the Islamic tradition. If you could, today or tomorrow, bring a little bit more light about that. For me, this is a crucial issue.
Yeah, I agree with you.
Thank you. Moreover, I read a little bit about the sect of Kalam al-Shari.
Yes,
and so I know a little bit this problem in the Islamic tradition. Yeah. But thank you.
Is this a quick one?
Well, I think it's quick. Yes, it's just a question that I think there's what I have read is that there was an element within Islam of utilitarianism for science, so that only science could be pursued if it had a direct practical relevance, and so therefore more theoretical stuff was neglected at some point. Is there something?
Yes and no, because as I mentioned regarding Al-Khwarizmi, for example, in his development of algebra, the way he presents it in the book, he first lines up all the benefits of this new science that I'm developing. And so he says it can be used for inheritance, and it can be used for calculating this, and for measuring that, etc., so that it can be accepted. But as I also mentioned in that famous correspondence, which to me is illuminating, between Al-Biruni and Ibn Sina, practically none of the questions that were raised had anything to do with practical usage. They were all, I'll give you an example. Why does Aristotle refuse the possibility of the existence of other worlds different from ours? It's like, excuse me, who cares? I mean, if we put ourselves in that utilitarian perspective, it would be who cares? But no, these were serious questions. Why does water freeze up, when it freezes up, float on liquid water? Think about it. And it wasn't for practical usage. Can you explain to me Aristotle's or the classical Greek theory of vision, knowing that we can see underwater, but water is supposedly an opaque medium? So how can vision proceed through rays of light, etc. when we... I was like, oh, wow. Physics. Physics. And sometimes very theoretical, sometimes very practical. All kinds.
Well, thank you very